exponential function is a function where x is the exponent. In the case of these two equations, even though the first one has an exponent on it, it is the second equation that is exponential. In general, we write it in the form of y equals a times c to the exponent x, where a is the initial value, or the starting amount, y is the final value, or the ending amount, c is the rate of change, growth or decay, and x is the time. It's important to note that your time always has to be measured in the same units as your rate of growth or decay. If you're talking minutes or days, both of them have to be in the same units. In a word problem, we can determine c as follows. If we're given words like doubles, then we know c is 2. If it says triples, then we know c is 3. If it says half, then c is 1/2 or 0.5, and so on. If in the explanation of the problem we're given the growth or decay as a percentage, in order to find the value for c, we need to add that value divided by 100 to 1. Or in the case of decay, we subtract it from 1. Let's take a look at an example. The first thing I'm going to do is write down the equation again. So I've got it in front of me. Y equals a times c to the exponent x. Once I've done that, I'm then going to look at my question and identify each of the key pieces here. So I've got 1,000 bacteria. That is my initial value, which is a. I'm being asked to find what the population is later. That's my y value. The period, x, is 4 days. The final thing I need to look at is the c value. 3% is 0.03. However, remember that when we get our increase in a percentage, we're supposed to take that and add it to 1, because it's increasing. Now I can go ahead and plug each of those numbers into my initial equation. So the a value is 1,000, the c value is 1.03, and the x value is 4. It was important to note that both the rate and the period were already in days, so we didn't have to make any changes there. Go ahead and do this math. Got 1,000. When I take 1.03 and raise it to the exponent 4, I get 1.1255. Multiplying that out, I get 1,125 and a half. But you can't have a half bacteria, so we'll just call it 1,125. Let's take a look at another example. The first thing I'm going to do is write out the equation so I have it in front of me. Y equals a times c to the exponent x. Looking for the a value, that's the initial value, is 800. The c value tells us we decrease by half every 6 months, so that's 0.5 every 6 months. Finally, the x value, or the term or the period, is 4 years. However, that's in years, and our c value is in months. We need to have these in the same units. We take the 4 years and ask, how many 6-month periods are there in 4 years? So I'm going to take that 4 years and convert it into months, which gives me 48, and then I'm going to divide that by 6 to get it into 6-month periods, and I get an answer of 8. So I've now got all of the pieces I need to go ahead and complete the equation. So y is equal to 800 times the c value, which is 0.5, to the exponent x, which is 8. So we've got 800 times 0.5 to the 8th is 0.0039. And when I multiply that out, I get 3 and some decimals. So at that point, there are only 3 fish left. Let's look at another example. As always, I'm going to start off by writing out my equation. Y equals a times c to the exponent x. Now I'll read through the problem. A city has a population of 30,000 people. It could tip off that that's likely the initial value, so I'm going to say that a is equal to 30,000. The population is declining, so I know it's going to be getting smaller, and I'm given a percentage rate. So my c is going to be 1 minus 12%, which is 0.12. and we're asked for the population after 7 years. So x is equal to 7. The rate of change of the population was in years as well, so the fact that my term is also in years is convenient. I've got everything I need now to go ahead and fill in the equation. 30,000 times the c value, which is 1 minus 0.12, to the exponent 7, which is 30,000 times 0.88 to the exponent 7th, which is 30,000 times 0.4086, which gives us a population of 12,260 people. Sometimes we need to solve a problem where we're looking for one of the other variables in the equation, so we can either be looking for a or c in this case. We can either plug in the variables and rearrange the equation, or we can use the equations after they've already been rearranged using algebra. Let's take a look at an example. It's expected that the value of a stock will triple every 6 months. After 1 year, the value of the stock is $10.80. What was the initial value of the stock? Since we're being asked for the initial value, I know that I'm going to be looking for A. That's the unknown. The final value of the stock, Y, is equal to $10.80. We're told that the stock triples every 6 months. So C is equal to 3 every 6 months. So now I need to find X. It tells me we're looking at a period of 1 year, but our rate of change is in 6-month periods or half years, so I actually have 2 6-month periods. With that information, I can then go ahead and use that first formula and substitute in the values. Y is 1080 divided by 3 to the exponent 2. Solving, I've got 1080 divided by 9, which is 1.2 or $1.20. Therefore, the initial value is $1.20. This question is dealing with the Consumer Price Index. A grocery basket costs $240 in 2018. If the cost of the same basket will be $269.97 in 2021, what was the annual inflation rate during this time? I'm told that I'm looking for the annual inflation rate, so I know that I'm going to be looking to find C. Now I need to find A, X, and Y. I'm told that the grocery basket initially cost $240, so there's my A value. It ends up costing $269.97, so that's my Y value. Now I just need to find the X. Going from 2018 to 2021 is a 3-year period. Now I can go ahead and use the equation that we were shown previously, where C is equal to the X root of Y over A. I can now plug in the values. I'm looking for the cube root of 269.97 divided by 240. So I'm looking for the cube root of 1.124. Doing that on my calculator, I get 1.04. When I know that C is 1 plus the rate of change, I can focus just on the second part of that, which is 0.04. 0.04 is 4%. So the annual inflation over this time was 4%. Try the practice questions.